Hello everyone. This video encompasses the information for today, Tuesday, and tomorrow, Wednesday, for degrees, notation, and radians. This should be review for the most part from geometry, but in case it's not, there are some additional review videos in the previous courses folder. So, degrees. What's important about them and when do we use them? Degrees are our standard, or the previous standard, of measuring angles of a circle. Specifically, there are 360 degrees in a circle. Domains of circles are going to run between 0 degrees and 360 degrees for one complete rotation. Now, there are two ways of talking about degrees. We can use either what is known as the degree minute second, or DMS notation. That is used often in nautical measurements or airline measurements when charting out specific flight paths or specific directions that you're traveling. Or decimal notation, which is often used in problems relating to shapes, angles of like 14.7 degrees. But regardless of what notation we're using, whether DMS or decimal, it is possible to convert from one to the other. To convert from DMS to decimal, we're essentially going to write out the DMS as a sum, multiply by a fraction, multiply by another fraction, use our order of operations, and then add up the decimals. If you recall, multiplying by fractions is the same as dividing. Whereas if we're going from decimal to DMS, we're going to write the decimal degrees as the sum of the degrees, sum of the decimals. We'll multiply the decimals by 60 minutes, take whatever answer is left over there, and take those decimals, multiply that by 60 seconds, and write it out as a sum of DMS notation to put it into DMS form. Now, what do I mean by that? Well, let's look at some practice problems. So firstly, DMS to decimal. Given the setup of 40 degrees, 10 seconds, and 25 minutes, we want to convert this into a decimal notation. So first things first, I'm going to write it out as a sum. I have my 40 plus my 10 plus my 25. Then I'm going to multiply my minutes by 1 over 60, which is the same as dividing it by 60. I'm then going to multiply my seconds by 1 over 60 times 1 over 60, which is the same as 1 over 3,600. Plug these into my calculator to get my nice little decimals, in which case it should be approximately 40 plus 0.166 plus 0.00694. Sum them up, and we'll end up with our decimal notation of 40.17361 degrees. Let's take a look at some additional practice. So 9 degrees, 9 seconds, 9 degrees, 9 minutes, 9 seconds. Convert that into decimal notation. Well, I'm going to sum them up. So I have 9 plus 9 plus 9. I'm going to take my minutes, divide that by 60. Take my seconds, divide that by 3,600. Run them through my calculator, sum them up, and it should give us somewhere along the lines of 9.1525 degrees. 1 degree, 2 minutes, and 3 seconds. Same sort of thing. set them up as a summation problem, 1 plus 2 plus 3. Divide the minutes by 60. Divide the seconds by 3,600. Run our order of operations, sum them up, and that should give us 1.03417 degrees. Decimal to DMS, we're going to basically do the inverse. We're going to take our 40.32, and that 40 will become our leading degrees. To find our minutes, we're going to take this decimal 32 and multiply that by 60, which will give us 19.2. That 19 will come down to give us our minutes. And then this 0.2, we're going to multiply that by 60, which will give us 12, which then becomes our seconds. So 40.32 degrees is the same as 40 degrees, 19 minutes, and 12 seconds. Some practice problems. 18.255. Well, that 18 is going to come down. Then I'm going to multiply decimal 255 by 60, which will give me 15.3. That 15 is going to come down. And then I'll take this 0.3, multiply that by 60, which will give me 18. So my answer in this case, 18.255 degrees, is the same as 18 degrees, 15 minutes, and 18 seconds. 19.99. Well, my 19 comes down. I'm going to take my 0.99. I'm going to multiply that by 60, which will give me 59.4. 59 comes down. Take my 0.4, multiply that by 60, which then gives me 24, giving us the DMS notation of 19 degrees, 59 minutes, and 24 seconds. All right, so radians. Radians are essentially going to be used for natural phenomenon. Radians are also an SI unit, much like Celsius or meters or liters. Radians are a unit that, while it still measures degrees, what we call degrees, it is a more natural way of measuring degrees. I'm going to put a video up in the previous courses folder about where the radians are being derived from. But essentially, we're using them for, to talk about circles that have an internal mechanism of a measurement between 0 and 2 pi. You might remember the 2 pi because it comes up in the circumference of a circle. The equation, C equals 2 pi r. Well, the relationship of the circumference, the radians, is 2 pi. Specifically, it takes 2 pi radians to make one circumference of a circle. So we're essentially using the radians for a circle whenever we're talking about the relationship between the radius themselves and a given length of movement along a circle. Let's see. It's important to note that degrees do not cleanly translate into radians. That is to say that 40 degrees is not the same as 40 radians. There is a conversion unit. The conversion unit is approximately, 1 rad is approximately 57 degrees. But the video that will be in the previous courses folder will go into more detail as far as deriving the radians. And I'll be talking about it more in the future when we talk about the unit circles. So what happens if we have degrees and we need to turn them into radians? Or if we have radians and we need to turn them into degrees? Well, we're going to use a fairly simple setup for them. Say, for instance, we had 90 degrees. I wanted to turn that into radians. Well, I would take my whatever measurement I have, whatever my original degree measurement is, I'd multiply that by pi over 180. That will give me my new degree measurement, my new theta measurement in radians. So 90 degrees times pi over 180 degrees would end up giving us 90 pi over 180, which simplifies to pi over 2. We'll do the inverse when we want to go from radians to degrees. Say, for instance, we had pi over 3 radians that we want to convert into degrees. Well, I'll take my theta measurement in radians. I'll multiply that by my 180 degrees over pi, and that'll give me my degree measurement. So pi over 3, we're going to multiply that by 180 over pi. Pi cancels out, leaves us with 180 degrees over 3, which simplifies down to 60 degrees. And now for some practice problems. Ideally, you should be doing these before you check this video to get the answers, but let's go through them step by step. For each of these, we want to convert into degrees or radians as appropriate. So if I'm starting with negative 45 degrees, I want to turn that into radians. So I'm going to take my degree measurement, negative 45 degrees. I'm going to multiply that by pi over 180, which will give me my new answer. Well, negative 45 pi over 180, which simplifies down to, pi over 4, but it's a negative pi over 4 because we had a negative 45 degrees. "90 degrees. Well, we did this one previously from the example, but once more, we have our 90 degrees. We're going to multiply that by pi over 180, which will give us 90 pi over 180. 90 over 180 simplifies into pi over 2. Pi over 3. To convert from radians to degrees, I'm going to take my pi over 3, just like I did in the example. I'm going to multiply that by 180 over pi. Pi's cancel out. 180 over 3, which is the same as 60 degrees. 11 pi over 6. Well, nothing changes. Got my 11 pi over 6. Going to multiply that by my 180 over pi. Those will cancel out. That'll give us 1,980 over 6, which simplifies down to 330 degrees. You're welcome to use a quick little four-function calculator in solving these if you so desire. Those, folks, are the practice problems for degrees to radians. There will be an assignment in the Wednesday folder related to this. Please complete it by Friday.